240. Okay, so let's get started. We are going to do patterns in inductive reasoning. So the first thing we have is our definition. So inductive reasoning is reasoning based on patterns you observe.
It'd be the patterns, actually.
Yeah. That's not what it is. Reasoning based on patterns you observe. Okay. So there's tons of patterns in life, numbers, shapes. You can see patterns in science, like when you look under microscopic things, like there's patterns in them. So inductive reasoning is reasoning based on patterns you observe. So we're going to look at numbers and shapes, and you're going to predict the next one. So, here are numbers and shapes. On your homework, you're going to have numbers. Some of them are kind of hard. Like, you have to look more into them than the obvious. Like, you have to think about it. So these ones are kind of pretty obvious. So, to get from 3 to 9.
Times 3.
Times 3.
To get from 9 to 27.
3 times 3.
So.
Times 3.
So, you want to get the next two terms. So, you're going to take 81 times 3.
243. Quick math in my
243.
head.
I'm smart.
No, you use a calculator.
And then you want to take 243 times 3, and you get.
Wait, don't say it. It said 726 or no.
29. 729. So each one of those multiply by 3. So you could keep going. You would multiply 729 by 3, but you can stop there. So the next one, sometimes with shapes you'll have like 2 patterns. This one only has 1, because do you see how they're all circles? So they're still going to stay circles. So you have a circle with 3 sides inside, a circle with a shape with 4 sides, a circle with a shape with 5 sides. So what should be next?
6 and 7.
6 and 7.
How are we supposed to do that on here?
You can't.
Yeah.
So you can write like circle with.
Too cool.
You can write circle with hexagon, circle with septagon.
Septagon has 7 sides.
6. Good job, Frankie. Sides. Would look something like that. 7 sides is pretty tough, but I'll do my best.
You got Mrs. Jeremita. Mayor Jeremita. What's over there?
1, 2, 3, 4, 5, 6, 7. So that's pretty poor, but this would have 6. That would have 7. Does that make sense?
Yes.
Sometimes the shape outside changes too. So with shapes, there's sometimes 2 patterns you have to identify. In this one, we only had 1. So if you're typing it, write circle with 6-sided figure or hexagon, circle with 7-sided figure or septagon. I want you guys to try these 2. So take some time and try these 2, and then we'll do them on the board. Okay, so for A, if you did A, these go up by or down by what?
5.
So you're subtracting 5 each time. So you should have 25, 20. Does that make sense? Make sure you identify the pattern there so you can see what you did. So write like -5 and then do your thing. Just so I know that you actually knew what you were doing. Like on a test, I'd like to see that you knew what the pattern was. For this one, you have square, diamond, or rectangle, diamond, and then you have rectangle. So the next one should be what you already had, but you should add a diamond in it. Does that make sense? So then the next one, you're going to take what I just drew, but you're going to put another rectangle in the middle. So you would just keep doing that. It kind of would create an optical illusion, like one of those things that you feel like you're going into it. Like that's, if you kept going, it would just get so small, technically go on forever, but you wouldn't be able to draw it small enough for it to go on.
I'm sweating right now.
Good. Yeah, it's just a lot of work to draw it on your computer. Are you guys okay with this?
Yes, ma'am.
Okay.
Wait. I gotta make it perfect.
So, we have another definition. This definition is conjecture. A conjecture is a conclusion you reach using inductive reasoning. So, a conclusion
Please look at that.
you reach using inductive reasoning. So you guys do this in life. So like when you see a pattern, you can then make a conclusion as to what's going to happen every time something happens. So you look at a pattern and then you make a conjecture, so a conclusion based off of whatever pattern you're looking at. When we talk about deductive reasoning, the difference is in deductive reasoning, there's like a process. So it's like science. So in deductive reasoning, which we'll talk about next week, you will have a process to go through. So you create like a hypothesis, and then you try to get that hypothesis to become true. So that's the difference between inductive and deductive in their endpoints. So we're going to talk about making conjectures. So using inductive reasoning, look at the circles. What conjecture can you make about the number of regions 20 diameters form? So listen, we have to look at the pattern and then use the pattern to make a conjecture. So if I have one diameter goes the whole way through your circle from side to side. If you have one diameter, how many regions do I have? 2. So 1 equals 2 regions, right?
40.
Let's keep doing this. So 2 diameters. How many regions are with 2 diameters? 4 regions.
4.
How about with 3?
6.
So what conjecture can we make? So for each diameter, how many regions are there?
Double the amount.
Double. So you would say regions are double
For 3, if you had 2, it's 5.
the diameter, right? Regions are double the diameter. So if you have 20 diameters, you're going to double that to have 40 regions. Does that make sense? So that's what inductive reasoning is. You look at a pattern and then predict. So we looked at the pattern and then we predicted that there should then be 40 regions for 20 diameters because it's double
Why are you so easy? Why did you put double D?
diameter. Regions are double, D represents diameter. Does that make sense?
I thought you meant to do like double
The diameter.
uh,
Yes. Does that make sense? Okay, you're going to try one next. So there's a pattern here. It says, what conjecture can you make about the 21st term in RWB, RWB? That's going to keep going. So what conjecture can you make about the 21st term? Take a second and try it out. Okay, so does anyone think they have the answer?
Yes.
What do you think the answer is?
I think it's B.
You think it's B?
Because
What do you think?
R.
You think it's R?
I agree with him.
You think it's B?
Yeah.
Okay. What do you think, Bowen?
B.
B. Blaze.
You have a smart.
B. It is going to be B. Did you think B? It is going to be B. The reasoning is, if you look at the pattern, this is the first, the second, and the third, and then you repeat 1, 2, 3. So you're repeating the same 3 things. 21 is a multiple of 3, correct?
Yeah.
So since 21 is a multiple of 3, whatever your third term is, that's going to be your 21st term because that would be a multiple of 3. So since B is your third term, B is also going to be your 21st term. Does that make sense?
Yeah.
So if I give you 5 things and I said, which one would be the 30th term, you would give me the 5th thing because that's a multiple of 5. Does that make sense? Because you'll see that again. You could keep going, but like if I said, what is the 42nd term? You're not going to want to write all the way out to 42 things. That's why they give you like crazy things. Like they give you 6 numbers and then they want you to go to the 21st. They can make you go to the 42nd if they want to. But you're not going to want to write 42 things out.
It would be B again.
It would, but that's what I'm saying. You don't want to write all that out.
Yeah.
Okay. So we're going to make a conjecture by collecting different steps here. So we're going to put number of terms, and we're going to put the sum. So it says, what conjecture can you make about the sum of the first 30 even terms? Does that make sense? Even terms. So for this one,
They're all even.
we're going to have 1, 2, 3, 4, 5, 6. So we're going to do 6 of them. So what's your first even term?
2.
2. The sum of that is 2. The sum of that is 2. So then you're going to do the first 2 terms. So if you start with 2, what's the next term? The sum of that is 6, right? Your first 3 terms. So you're going to have 2 and 4 plus the third one, which is now 6. This is going to be
12.
12.
That's quick math.
Then the fourth term, 2 plus 4 plus 6 plus 8.
1, 2.
It's going to be 20. Then you have 2 plus 4 plus 6 plus 8 plus 10.
30.
30. And then you have 2 plus 4 plus 6 plus 8 plus 10 plus 12.
42.
42. You get to 42. So we need to make a conjecture about this, about the first 30 even terms. Does that make sense? So we did the first 6 even terms. We need to make a conjecture. So I want you to look at not the numbers we added, but I want you to look at the term, so this is term numbers, and the sum. So I want you to compare these numbers with each other.
2 and 6, 3. 3 and 3, 4. 5. Times the one above it.
Times the one above it. So 1, the one above it's 2, you get the 2. 2, the one above it's 3, you get the 6. Does that make sense? So you take the term you're on and multiply it by the number of the number term. So if you're on term 1, multiply term 1 by 2, you get 2. Take the sum, multiply it, or take the term number you're on, multiply the one above it, you get 6. So if you're going to the 30th term, you want to multiply it by the term above it. So what would the term above it be?
29.
Above 30.
31.
31. So we had 1 times 2 is 2. 2 times 3 is 6. I'm going to do one more. 3 times 4 is 12. So we're going to take the term and multiply it by the term above it. So we're going to do 30 times 31.
Wait, I got quick
Equals
math.
360.
No.
930.
930. It says 930. Yeah, 930.
Yeah, it is 930. I'm just close.
So the sum of the first 30 terms is going to be
Yeah, you're right.
930. So instead of going all the way out to 30, you can see the pattern and do that. Does that make sense?
Yeah.
So for this pattern, you take the term you're on and multiply it by the next term number. So if you're on term 3, multiply by 4, you get to 12. Okay? You're going to do the exact same thing on the next one. So look at your next one on your notes and do the exact same thing for that. So whatever it's asking you, that's what you're going to do. So it says
First 30 odd numbers.
first 30 odd numbers. So you're doing the same thing. So these should be terms. 1, 2, 3, 4,
Odd.
3, 4, 5, 6. And then you're going to start with 1. So you're going to have 1, 1 and 3, 1, 3 and 5, 1, 3, 5 and 7. So do that. Work on that and then we'll go over it. So I'm going to start to write this. If you're working, like I said, keep working. Don't worry about what I'm writing. You keep working and try to figure out what the pattern is.
Ow.
Peppa, were you doing it like that?
Where's mine?
So you're comparing the term to the sum. You're comparing the term to the sum. So, to get from 1 to 1, you can't really see what's happening. To get from 2 to 4, you would multiply 2 to get to 4.
Multiplied by itself.
Right, you multiply it by itself, so you square it. So, to figure out the 30th, you're going to square it. So,
900 is the answer.
I'm going to do 2 squared is 4, 3 squared is 9, 4 squared is 16. So that's the pattern that we see. So to get to the 30th, you're going to do 30 squared,
900.
which would be 900. Does that make sense? So you're squaring the term to get the sum of whatever row you're on. So the sum of the first 30 terms is going to be 30 squared, which is 900. Does that make sense to everyone? You see how you see this pattern? So you're physically seeing a pattern and then making a conjecture. Seems pretty simple, I think. Are you good with this?
Yep.
Okay.
I'm worried.
So this is using a table or a graph, not a table. We just use a table. This is using a graph to predict. So this is backpack sales, which is pretty relevant because it's back to school. Sales of backpacks at a nationwide company decreased over a period of 6 consecutive months. What conjecture can you make about the number of backpacks the company will sell in May? So if you look at that, N stands for November. So you're going November, December, January, February, March, April, May. So what can we predict May is going to be? Let's look. So on average, you go down about, so from November to December, you went down almost 500. From December to January, you went down, again, a little less than 500, but it's still close. January and February, that's Christmas, like after Christmas, no one's really buying backpacks. So the sales really decreased then. It went about almost down like 1,000. And then you start back on the almost 500. So we can make a conjecture that it's going to go down about 500, right? Because that seems to be the pattern with taking out the outliers. So if April is, we'll say 8,500, it'll be about 8,000. So I'm going to say my conjecture is going to be the backpacks will go down about 500 more, and I'm going to say roughly 8,000. It's going to be a little less than that, but roughly it'll be about 8,000. Does that make sense? So you just looked. You're just looking at it and seeing what the pattern is. So I want you guys to answer the next question. I think it deals with the same thing, maybe? Same graph. So that was May. June is going to be the next month. So if you're going down about 500, what do you think is going to happen in June? Right. And then I want you to do B. Is it reasonable to use the graph to make a conjecture for August? So think about that one, and then we will. Okay, so what do you think about June? What do you think about June?
It's going to be 700.
So you think it's going to go down again?
Yeah.
About 500, at least 500. I would think it would go down more than that because what's over in June? School. So I would say it might go down even more than 500 because no one's buying book bags when school's over, right? So like it would be at least 7,500 or less, I would say. So I would say A, sales would be 7,500 or less. It's definitely not going to go up unless your parents are the type that want to get the discounts on book bags because they'll probably be on sale then because like I said, they're not going to be selling them. Is it reasonable to use that graph for August?
No.
What do you think, Ryan?
It's unreasonable. It's unreasonable because as school starts, people are going to find.
Right. It is very unreasonable because August is going to be back to school, so sales should be at their highest in August and September. So I would say B, unreasonable. Sales should, with an S, should be at their highest. Due to, and then I worked in the retail industry. It's BTS. Back to school, BTS, due to back to school. So everything that you, like clothing, shoes, book bags, like August is their biggest month, especially like kids' clothing, kids' shoes, because it's back to school. So it is very unreasonable to use that graph because August should be the highest month and September should be a close second because sometimes people wait to go back to school to see what they need. So that's what you would get for those. We have one more to do. One more to do. So a counterexample. We already talked about a counterexample, but I don't think we ever actually defined it. A counterexample is an example that shows that a conjecture is incorrect. So an example.
I looked up and it's an example that poses a contradiction in idea or theory.
Right. That shows a conjecture is incorrect. So I know that in my college prep class, the one question is, the one thing states no singers are ever in movies, and they have to give counterexamples, and I always say like Eminem has his own movie, and Tim McGraw is in The Blind Side, and Taylor Swift is in Valentine's Day. Like those would be counterexamples to prove that's wrong. So you've done this already by saying like false, rhombus. That was your counterexample. So this is just a different definition for it because now we have a conjecture that we know how to make. So we're going to give counterexamples to show why these are false. So it says if a month starts with the letter J, then it's a summer month. What summer month starts with the letter? What is not a summer month?
January.
January. So your counterexample would be January is a winter month. January, at least here, is a winter month. It's going to snow. You cannot, okay, you can connect any 3 points to form a triangle. Not if they're on a straight line, right. So I would say, I would literally do this. Not a triangle, right?
Why can't do it?
Not a triangle. So if you're typing, you can write 3 points in a straight line would not make a triangle. 3 points in a straight line would not make a triangle. I just literally showed you that I drew 3 points, connected them, no triangle.
I got the next one.
When you multiply a number by 2, the product is greater than the original number.
0 times 2.
0 times 2, that would work. 0 times 2 is equal to 0. 0 is not greater than 0. 0 is equal to 0. So that would be a counterexample to prove that statement false.
Or a negative number.
Or you could do a negative number. Or you could do a negative number. Because negative 2 times 2 is negative 4. Negative 4 is less than negative 2. I want you to do the next 3. Give counter examples for each one of those statements, and then we'll be done.
Let's get it.
So you need to give counter examples for these. So A, someone give me a red flower that you use.
Poppy.
Or whatever you said,
Poppy.
an amarilla, what?
Poppy is
A poppy.
I
A
looked it
poppy
up.
can be red, and then a poinsettia can be red. That's the one that I think of, but I didn't remember the name. So
Poppy.
poppy is easier to write. So you could have said a poppy. You could have said a poinsettia. Any other red flower. B says one and only one plane exists through any 3 points.
Multi-plane.
We didn't learn about planes yet because we usually do that first. You can have more than one plane through any 3 points. My example, so if you have 3 points in a straight line, you can have a plane.
In a triangle.
That's not what I wanted. Any 3 points. You could have a plane. So if you have 3 points this way, you could have a plane this way, but you could also have a plane
Oh my gosh, you're stupid.
like that way. So it's in one and in the other. Does that make sense? So like the plane goes along the points, and then the plane like encompasses the points. So those points are technically on both planes. We will learn about that, just obviously we didn't yet. C says, when you multiply a number by 3, the product is divisible by 6. The first thing I think of is 3 times 7.
3 times 1.
3 times 3, 3 times 1. Any one of those would work.
That's 7.
3 times 7 is 21. 21 divided by 6 cannot happen. Does that make sense?
Yes.
Okay, so you have homework. It's going to be due Monday. I will post that, and then you can get started whenever you please. But it's due Monday. I think there's 18 problems. It's from yesterday's notes and today's notes.
Let's get it.